Hello, everybody. Here we have this function f of x equals 10 plus 7x squared minus 2x. And it says to determine if f of x is a polynomial, and if it is, then put it in standard form. All right, we did that in the previous video. And it is a polynomial, and the standard form is 7x squared minus 2x plus 10. And in the previous video, we determined its degree, which was 2. And also in that video, we determined the leading term and the constant term, which are 7x squared and 10 respectively. Now, let's find the maximum total number of possible zeros of x. Well, that happens to be the degree. And degree, we said earlier, was 2. So that's the maximum number of possible zeros. And I should say of f of x. Okay, so the maximum total number of possible zeros of f of x is 2. Now, let's get more information on whether they're positive or negative or none or neither. So he says, using Descartes' rule of signs, uh, let's use that rule of signs to do that. Okay, now there's a nice calculator for that. And here it is right here at a2zmath.com. And let's put it in. All right, we can go ahead and put in the original one, as it doesn't have to be in standard form. Either way is fine. So let's just put in. All right, now we have to enter in the f of x part, so just the other part of it, which is 10 plus 7x to the 2. All right, and this upside down v is called a caret, and a caret represents exponent. So this is 10 plus 7x to the 2 minus 2x. All right, let's click find. See what it says. All right, now it actually put it in standard form for us, which is nice. And so that's one benefit of standard form, is so that we can use it to use Descartes' rule of signs. So make sure the polynomial is in standard form first. And so they put it in standard form for us, which is 7x squared minus 2x plus 10. And so now we figure out the sign of each of the terms there. So 7x squared is a positive, then 2x is a negative, plus 10 is a positive. And so now we count the number of times the sign changed going from left to right. So from plus to minus, that changed 1, and then minus back to plus, that's 2. So there are 2 sign changes, so that means, now it says here that the number of positive real roots of f of x is the same as the number of changes in sign of the coefficients of f of x, or less than this by an even number. So here, the sign changed 2 times, and so we subtract 2 each time until we get to 0. And so if we do 2 minus 2, it's 0. And so what this is saying is that there are either 2 or 0 positive real roots. So let's copy that in. Okay, now let's discover the negative roots. All right, now to do this, we find f of negative x. So that means everywhere I see an x, replace it with a negative x. And so they did that in the standard form. Um, and then they simplified. So negative x squared is actually negative x times negative x, which is x squared. That's because a negative times a negative is a positive. And then we have a negative 2 times negative x, which is plus 2x. And so f of negative x is 7x squared plus 2x plus 10. All right, now here we count the sign changes again in the f of negative x. And notice that all the terms are positive, right? 7x squared, 2x, and 10 are all positive, and so it didn't change at all. So since there's no sign changes, there are no negative real roots. Okay, and just like before, um, how many ever roots you have, subtract it by 2 to get other possibilities. But here, since there's zero sign changes, then 0 is all we have because we can't go lower than 0. But in general, subtract 2 each time. So if it says 10, then either have 10 or 8 or 6 or 4 or 2 or 0 roots. All right. So just keep subtracting 2 until you get to 0. That's how that works. Okay, so let's summarize here. There's either 2 or 0 positive real roots, and there's definitely no negative real roots. Okay, well, let's see what we have definitely. Okay, so these are just telling us the possible positive and negative real roots. We know that there's definitely no negative real roots. There's either 2 or 0. But let's get the full story by using Wolfram alpha to find all the exact solutions, or at the very least, all the approximate solutions. All right, here's Wolfram alpha right here. Let's ask it to solve the equation. Okay, we'll go back to the original f of x. Okay, so what we're going to do is we're going to solve that part of the equation. So we're given 10 plus 7x squared minus 2x, and we're going to solve it. We're going to set that equal to 0 and solve it. Okay, so let's solve 10 plus 7x squared minus 2x equals 0. And let's see what it says. And we get these answers right here. Okay, we actually get imaginary answers. So 1/7 times 1 minus I squared of 69, and 1/7 times 1 plus I squared of 69. And so it looks like in the end, we got 0 positive real roots and 0 negative real roots. That's because both of the roots were complex. And remember, keep in mind that degree told us the maximum number of roots, and the maximum number of roots is 2 because the degree was 2. And looks like now the final story is the final answer is 2 imaginary number solutions. Okay, so that's how to take a polynomial and then determine how many possible positive and negative real solutions it has using, or how many positive or negative real zeros it has using Descartes' rule of signs, and then ultimately determine what those zeros are.